aka the teacher. My pupils calls me the teacher. We are here to do mathematics indeed. Be ready for the lesson that is coming forth. If you are new to this channel, you are welcome, please. But today we are dealing with the trigonometric ratios, abbreviated as trig ratios. First of all, before we come to this question, we should be able to identify the sides of a right-angled triangle. And in this case, we have this model of a right-angled triangle where we have the longest side of a right-angled triangle is called the hypotenuse. The shorter side touching the angle is called the adjacent. The side facing the angle is called the opposite side. So, in a situation where you are provided with the opposite and the hypotenuse, you have this opposite and the hypotenuse, you can use one of the trigonometric ratios, and that is the sine ratio. The sine ratio states that sine angle is equal to opposite over hypotenuse, which means sine of this angle is equal to opposite over hypotenuse. We also have another trigonometric ratio, which is the cosine ratio. Cos angle is equal to adjacent over hypotenuse. So meaning that you can say cos of this angle is equal to the adjacent over the hypotenuse. Then we have the third trigonometric ratio, which is the tangent ratio. This one here. Tan angle is equal to opposite over adjacent. So meaning that tangent of this angle is equal to opposite over the adjacent. These three trigonometric ratios are modeled through this. We call it socatoa. So this is actually a summary of what we have on these papers, where the so is for sine angle is equal to opposite over hypotenuse, meaning this is sine angle, this is opposite, this is hypotenuse. Then the next one is the cos. This car in black, it stands for cos angle, which is cos angle is equal to A stands for adjacent, then H stands for hypotenuse. Then we have the last part, which is the toa. We have this is tan angle is equal to O, which is the opposite, and A is the adjacent. So data, we identify the sides that we have on this paper. Like we said here, we said that the longest side of a right angle triangle is the hypotenuse. So in this case, do we have the hypotenuse? There is nothing written on the hypotenuse. Then we also said that the shorter side touching the angle is the adjacent. Do we have the adjacent? Yes, this is a shorter side touching the angle. Hence we can say adjacent is equal to 9 centimeters. Then we also said that the side that is facing the angle is the opposite. So do we have the opposite? Looking at this, this is opposite to that. So we are saying opposite is equal to x. Data, we also have to consider that the theta, the angle itself, is that 47 degrees. After gathering this data, you now have to consider the trigonometric ratio that you are going to work with. What if we say sine angle, yes, the angle is there, is equal to opposite, yes, the opposite is there, over hypotenuse? No, we do not have the hypotenuse. So this one is disqualified. What if you say cos angle, yes, the angle is there, is equal to adjacent, yes, the adjacent is there, over hypotenuse, the hypotenuse is not there. So this is equally disqualified. What if we say tan angle is equal to opposite over adjacent? Therefore, the correct ratio that we can use is this tan ratio. Hence, we can proceed with that. Therefore, we are saying tan theta is equal to opposite over adjacent, of which the theta is the angle that we have, and the angle is right here. Hence, we can say tan angle, the angle is 47 degrees, is equal to the opposite. The opposite is that x over the adjacent, which is 9. Then at this point, you can consider this being written as a fraction so that you cross multiply. When you cross multiply, you are going to have 9 tan 47 degrees is equal to x. At this point, get your scientific calculator, make sure that it is in degrees. So when it is in degrees, just press 9, then tan 47 equals, it will give you that figure there. So the figure is 9.65. Therefore x is equal to 9.65 centimeters. The end of our lesson. Please, if you have not subscribed, this is the time to do so. It's mathematics all the way until Jesus Christ comes. Take a minute of your time and imagine the world without mathematics.